Hi guys, BuildZoid here, and today we're going to be taking a look at another one of my ill-advised purchasing decisions from eBay. And before we get to what it is, I'm first going to show that it does, at the very least, turn on, which it didn't do when I purchased it, for way too much money. And by way too much, I'm talking like 80 quid, so yeah, let's turn it on. And I'm not going to let it go into Windows because it doesn't have much in the way of a heatsink, and ow, my fingers. So yeah, it turns on. We can't run anything because it's not finished. I've completely run out of solder. Like, I've run out of solder so much that I'm like scavenging like solder drips off of my desk, uh, in order to do some of the stuff that I've done to this card. So yeah. Um, and you may remember I was complaining about running out of solder in a previous video. I'm really good at procrastinating, so that's why I still don't have any solder. Anyway, let's get this out of the system and onto the desk. Move, please. Get out. There we go. Much better. Let's point the camera at this. Hide all of this. Over here. Zoom in. That's a bit too much. Zoom out. There we go. And actually, I'm pretty happy with it being pointed right here. There we go. There. So, yeah, what is it? Well, it is a GTX 1080 FTW EVGA card, and I picked it up on eBay as 4 parts not working for 80 quid, which again is way too much because the thing is, like, normally if I'm buying dead cards, I aim under 50 quid unless it's like rare or special in some way. And the thing is, this is a 1080 FTW. It's really not that special, but the seller did have a very clear picture of the crater that was in the VR that's in the PCB of this card. So I was like, well, that's exactly the kind of thing I want to work on. And so that's why I was willing to pay 80 quid for this thing. Which again is too much, but it was just like, this is exactly the kind of issue I wanted on a card. So we can't see the crater because we have this lovely Galax Hall of Fame power board in the way, and I'm probably not going to keep this on this card just because this is way too nice for just a GTX 1080, and I have other plans planned for this power board, but yeah, for just the initial testing, I literally don't have a more convenient power board. I love this thing. I'm really, really sad that Galax, I think they made 100 of them, and they sold them all, and they've not made any more since. And I'm kind of annoyed about that because I would be totally down to picking up like another, well, a lot of them. Because these are awesome. These are 16-phase, well, they're 16-phase power boards using a bunch of IR3555 power stages, so those are 60-amp power stages. And yeah, it's just great. And the main reason why it's so great is because it has a super convenient, like, layout for the actual hookup planes. So, like, you have ground here, you have ground here, then you have more ground over here, and then you just have VCore along right here. So yeah, this thing is just super, super convenient to hook up to cards because you have all of these options for ground connections as well as just, well, a really long ground over here as well as the really long V-core right on the edge. So yeah, I really like these. And I only have one of them, so it's kind of a problem. But yeah, so that's hooked up to this card right now. Now we can't look at the crater. Like, the thing is, when I take this off and then rearrange this, because the thing is, I'm probably going to end up, like, I was toying with the idea of powering this using an RX 480 VRM, but that didn't really have that VRM is really inconvenient to attach to things. So I'm not sure what I'm going to power it with. I might power it with the 8-phase off of a GTX or HD 7970. DirectCU2 HD 7970 8-phase. So yeah, I just need to repair that VRM because while I was trying to e-power it, I blew it up because I'm an idiot. So I need to fix it, and then we can put it on this card. That's probably, yeah, that actually seems like the most reasonable decision to me. Just use that VRM because that's like a good size for a card like this. And do believe you just get a ground strip and a V-core strip on it, and it's not like super, because like on the RX 480 VRM, there's just tiny little areas where you can get ground, and it's just like, well, that's super annoying to work with if you need a lot of high current, like if you need a solid high current connection, which a 1080 doesn't pull that much power, but it still pulls a decent amount of power. So I don't really want to use the RX 480 VRM for this. Anyway, yeah, so as to how do you hook up a power board like this? Well, you just desolder all the inductors for the V-core VRM, and you're done with that. As for the short circuit in the PCB, so that short circuit shorted out 12 volts, it shorted out ground, and it shorted out the 5-volt rail for the actual V-core, the 5-volt rail for the V-core VRM power stages. So the way I've solved that is I desoldered the inductor for that 5-volt rail, because we don't need it. I also desoldered the input filtering inductor for the V-core VRM, or half of the V-core VRM, because you have one half of the V-core VRM runs off of one 8-pin, the other half runs off of the other 8-pin, right? There's your two 8-pin power connectors. You'll notice that you probably noticed that I didn't have the 8 pins plugged in when I was turning on the card, and this is because I've completely rewired, well, it's not really that, well, yeah, I've rewired the card so that everything that's still on the card, which there's not that much on the card, like you have your memory VRM, you have the 5 volts for the memory VRM, you've got your PEX rail, and then you've got 1.8 volts rail, and then there's some minor regulators over here. So all of that still runs off of the GPU and entirely off of the PCIe slot. It used to be that some of that ran off of one of the 8 pins, or maybe both of the 8 pins. I'm not really sure. NVIDIA cards have unnecessarily complicated input power planes because we need to power balance the 8-pin power connectors. Like, why? Who cares? They're 8 pins. They can handle 300 watts each. Who just jam them right into, like, do it like AMD. Don't have any freaking current sensing circuitry. Well, actually, no. The current sensing circuitry is useful, but the current balancing stuff is just like, why is it there? Anyway, so yeah, I've completely rewired the card so that it runs entirely off of the PCIe slot, so we don't need to plug in the 8 pins because that's annoying when you've also got these 3 8 pins over here. And all of the, like, the memory power is not that, like, GDDR5X just doesn't pull that much power, so I'm not worried about, like, overloading the PCIe slot or anything like that. What else is there? Oh, I guess I should talk about why there's a crater in the PCB. Well, it's very simple. GTX 1080 FTW cards are a little bit famous, or maybe very famous. I don't know. But it was, a thing. That these just started randomly exploding for people. And basically the problem with these is EVGA got a batch of bad components. I can't tell you which components, but they got a batch of bad components. And yeah, those components explode. And there's not really anything you can do about it. They just up and explode. What's interesting, like, and the thing is, the card also was, like, when initially it came, like, when initially people started, experiencing the whole VRM catching fire on these, a lot of people initially were like, let's blame the VRM thermals because the way EVGA decided to cool the VRM on these cards is, well, kind of crap. And so the VRM runs at around 120 degrees, which is not ideal, in one way to put it. Technically speaking, that is in spec for basically everything that's in the VRM. Like your capacitors, it's in spec for those. Your power stages, it's in spec for those. All of the components, it's in spec. But the components do last longer if you don't run them at 120 degrees. And also, and also there's other cards with just run cooler at a similar price point. So it's just like, yeah, you should just have better VRM cooling. But ultimately, the VRM cooling does not change the fact that the defective components that these come with, they explode. And what I find really, and the reason why I'm pointing that out is because EVGA actually, like, sent out a bunch of, gave people the option to basically get a bunch of, like, extra thermal pads to install over the VRM to improve the VRM thermals. And this card actually came with that thermal pad kit installed when I got it. Which is also why we have this disgusting oily stain right over the V-core, like over the V-core VRM right here. So yeah, the previous owner of this card, or, like, I don't know if the seller, but somebody in the history of this card installed that, like, thermal upgrade kit on this card. Didn't do anything. The V-core VRM still exploded, which makes sense because there was actually, like, I remember seeing a case of one of these 1080 FTWs exploding while it was idling because, again, it's just defective components. They die. Anyway, So yeah, there's a crater in the PCB. I've just gone around that with the power board, and then I disconnected everything that it was shorting out, so that's great. No more short circuit. The thing that you need to do with this card to get the power, like to get it actually to fire up once you've butchered the VCore VRM like this, um, is, well, all of this right here. So what do we have going on? So the first thing is, so the important part is this red wire right here. It's not the two yellow wires. The two yellow wires are here for rewiring the PCIe slot to the 8 pins, and then this one wires up the other 8 pin. This jumper wire over here is just to disable the sensing pins, because an 8 pin, it's kind of like you'd assume an 8 pin is like 4 12-volt lines and 4 grounds, but actually it's 5 grounds and 3 12 volts, and it's just like, that's dumb in my opinion. But anyway, the reason why it's set up like that is because 2 of the ground pins are actually sense pins for detecting if the 8 pin, or if you have an 8 pin or a 6 pin connector plugged in. So if you plug in a 6 pin, it only connects one of the sense pins. If you plug in an 8 pin, it connects both of the sense pins to ground. And so it's like, that's how you can detect if you have an 8 pin or a 6 pin plugged in. Now, the thing is, if you just jump the 12 volts like I've done, the card will still think that there's no 8 pin plugged in because you haven't connected the sense pins. So I've jumped the sense pins with this wire right here. And I've also done that on the other 8 pin. You can't see it though because I have some tape here, because when I was soldering these wires into place, I was getting kind of concerned about like the insulation getting penetrated uh, by the pins, because the thing is, when you're soldering to like power planes like that, it takes quite a bit of heat, so the insulation gets really soft, and I was like, I don't really want it to short out. So I taped over, so I just have some tape over there to add a little bit of extra insulation. Anyway, so the important wire is this red wire. So this red wire goes over here. And it goes over here because this chip right over here is a integrated little buck converter for the 1.8 volt rail on this card. Now there's no documentation for that chip that I could find, mostly because the label on that chip is ADPG, which is just like, put that into Google and tell me what comes up, because it's not buck converters in my experience. And I also tried DuckDuckGo and all data sheet and like all of the usual, data sheet search suspects, and it's just like, nope, couldn't find what it is. There's a pretty good chance that the ADPG on marking on that chip isn't even like a part number. It's like a date code or something. Like a manufacturing code to indicate which batch it's from or something. So it's just like, this is useless. And anyway, so the problem here with getting this 1.8 volt to fire up is that 1.8 volt rail to turn on is that for whatever reason, when you screw up the VCore VRM like this and desolder the VCore VRM controller. And the reason why you do this is because the controller normally, like if you don't desolder the controller, it'll detect that you've done horrible, unspeakable things to the VCore VRM and complain very loudly to the GPU, which will then make the GPU not turn on any of the other rails because it'll think that there's something wrong with the VCore VRM. The solution to this is to remove the chip that tells the rest of the GPU that, hey, there's something wrong, because then there's nobody to tell anybody that there's a problem. So yeah, VCore controller gone. And this works on NVIDIA cards in my experience. On AMD cards, it doesn't work. AMD cards are way too freaking smart for their, AMD cards are obnoxiously smart about stuff going missing. So they just complain all the time if you do anything to them. That's this drastic, and so they're super annoying to power board. But NVIDIA cards are simple. You just desolder your controller, and most of the time that'll actually get them working. Now, this card that doesn't work, and I'll assume reference 1080s, it'll also not work because on, the thing is, this circuitry right here and a lot of the circuitry on this card is actually borrowed off of the reference 1080 PCB. In fact, as far as I can tell, what EVGA seems to have done is they took a reference 1080 and then just bolted on this bigger, better VRM, except for the part where their supplier for some of the components sent them a bunch of dodgy components. And so as much as this should actually be just a straight upgrade from the reference card, it does unfortunately explode. But that's not really EVGA's fault. So, sometimes your supplier sends you garbage. Can't do much about that. Anyway, so the thing is, This this voltage regulator wouldn't turn on when I first tried to fire this card up with the power board attached, and it turns out the reason for that is very, very simple. For whatever reason, it wasn't getting the input voltage that it needs to generate 1.8 volts. And the way I figured this out, because again, there's no documentation for that chip, is that same chip is used over on this side of the card for generating the 5 volts for the memory VRM. So I basically probed around how this chip is like, wired up, and I figured out there's a pin right under the pin right under the letter D is connected to the PCIe slot, the 12 volts of the PCIe slot, which tells us that it takes in 12 volts from the PCIe slot and converts that to 1.8 volts. Now, when I checked the same pin on this chip, and they both have the same ADPG markings, so I'm assuming they're this. So it should be the same chip, because what else would it be? So when I probed that same pin on this chip, I found out that it doesn't seem to be connected to any 12-volt power source, or 3.3 volts, or 5 volts, or really anything. Like, I don't know where it's supposed to get power from, but it wasn't getting power. So it's probably connected through some switches because, again, NVIDIA loves having overly complicated power distribution for no good reason. So the solution to that is I just, connected... so we're going to zoom in. Zoom? Ta-da. So I basically just connected this wire over here to this capacitor, and then there's like a unoccupied pad here, and then normally there would be a 0 ohm resistor right here, here. Right, so from this pad over to where that red wire is, there'd be a 0 ohm resistor. Now I've removed that resistor because, and I really shouldn't be calling it a resistor, it's just like a bridge, but it uses a resistor packet. Like, actually, I'm not sure if calling it a 0 ohm resistor is wrong or right. But anyway, like it looks like a resistor, like it looks like one of these, right? They have a 0 on them as well, so just kind of like bridges like that. Anyway, so I desoldered that, but not before I managed to blow up this trace right here. Now, I'm not too worried about this because that evidently isn't necessary for the functional operation of the GPU because the card still runs and that exploded. So when I first tried to turn this on, actually, I had a much longer red wire, and it was connected to the other side of that resistor, which doesn't matter. It's a 0 ohm resistor, so in both, like, it doesn't matter which side of the resistor you connect to. But the thing is, yeah, apparently this trace goes off somewhere, and yeah, when I had that red wire connected, when that resistor was still there and I first connected this up, this whole thing just, well, it didn't actually like vaporize the trace or anything, but the trace got really, really hot and it vaporized the solder mask. So I got a nice puff of smoke that I unfortunately didn't catch on camera, but I've decided that if I ever get my hands on another 1080, FTW or reference card, like any card with this 1.8 volt circuit, I'm blowing up that trace again. Just because I don't really consider that a very high risk explosion. So, we can have some fun on camera with like, oh, look what happens when you're reviving, like, like the thing is, you can just cut the trace or desolder the resistor, which is what I did here. And that's probably what you should do. It's much easier to just desolder the resistor. If you ever need to reconnect that trace, you can just solder back a jumper wire or even the same resistor again if you care enough to keep it. I don't. It's a 0 ohm resistor. A piece of wire has the same functionality. Anyway, so yeah, that's just 12 volts to that. And once you do that, this chip produces 1.8 volts. The memory VRM goes like, oh, 1.8 volts is present. That means I can turn on. Then your memory VRM turns on, and then the card works. Ta-da! Yeah, super simple. So that's assuming you want to bypass the entire vCore VRM. Like, that's the only reason to do something like this. Otherwise, this is completely pointless. But the reason why the memory VRM only turns on once the 1.8 volts is present is actually really important. You do not want to turn on the memory VRM before the 1.8 volts turns on. And the reason for this is that the 1.8 volts is the VPP rail for the GDDR5X memory chips. And the memory rail is the 1.35 volts rail for the GDDR5X memory chips. And if you've ever read the GDDR5X documentation from Micron, you would know that there's not many safe operating requirements for these chips in terms of voltages. They can actually tolerate very high memory voltage. I think technically speaking, I think the documentation is like you can technically expose them up to 2 volts and they shouldn't take permanent damage unless this rail is higher than the 1.8 volt rail. So if VPP is less than VDD, or I think it's also referred to as VDDQ. Like VDDQ, if I'm not mistaken, is generated off of VDD. But anyway, yeah, if your VMEM is higher than VPP, uh, it should cause permanent damage to the memory chips. Now, I say should because I've never tested if it actually does. But the documentation says you shouldn't do that. And that's why I've never done that, and I don't want to find out. So yeah, you have to have the, like, so you should, so unless you're very adventurous, you really should get the 1.8 volts running first. And then once you have your 1.8 volts, then you can start worrying about getting the memory voltage up and running. And once the memory voltage is up and running, the card should just turn on, because the PEX VRM seems like the PCIe interface rail, which also known as PEX or PLL, depending on which GPU vendor you're looking at, is like this rail down here. Yeah, that should just turn like, well, this I'm not sure. I'm not sure if it turns on with the memory or if this was running before the memory was running. I can't remember. But anyway, this now turns on, so this doesn't care about everything I did, or at least does, like, once the memory is up and running, this should be running, like this should be running as well. So yeah, that's what I've done so far with the card. It's very much not finished, right? Like, I mean, the power connections I have from the e-power from the Hall of Fame power board to the card, this is grossly inadequate. Which, yeah, it's just like, this is just for testing. The other thing is, like, GDDR5X scales with memory voltage. It scales great with memory voltage, so I definitely need to mod the memory VRM so that we can get some memory voltage control. Then PEX rail, well, the thing is, even regardless of which power board I put on this, the PEX rail is very accessible, so I'm like, I can mod that at any time. Memory VRM, like, it just needs memory voltage control, then we're done. It might have OCP. Maybe I'll need to disable that. Other than that, I'll probably, actually, no, not probably. I'll definitely be adding some just structural support to the card in the form of, like, in the form of this, right? This wire right here, that's, I believe, that's like 10 or 12 standard wire gauge. It's solid copper, so it's very rigid. And so I'll probably just have one going from here to here and here to here so that the card doesn't flex, this way. So yeah, and other than that, maybe I'll add some extra capacitors behind the core, maybe also some extra capacitors for the memory. Like, the thing is, when I was working on the GTX 1080 Ti, the memory did actually, like, benefit, and I think also GTX 1070, like, both cards benefited a decent amount from adding extra capacitors to the memory rail. So now on this card, I'm not sure if it'll make that much of a difference, because, like, this is a substantial upgrade over what you normally get on a reference 1080 in terms of output filtering for the memory VRM. But in my experience, there are very, very few situations where you can have too many capacitors. Most of the time, I've run into that very rarely, that having too many capacitors was actually a problem. So yeah, I'm totally gonna probably, like, if I'm bored, this will end up with a bunch of extra memory capacitors just because I'm bored. And yeah, that's basically all I want to really say about this card for now. When I actually, like, I think when I finally have, like, a finished, when I get it finished, the plan is I'm actually going to have pictures of, like, the damage to the PCB, because we can't see the crater in the PCB, so it looks like I've butchered a completely a perfectly good card. I'll also have better pictures showing, like, where the PCIe slot to the 8-pin connection is happening, and that kind of thing. So, more detail. I'll also cover how to mod the memory voltage and that kind of thing as well. But for now, I've just got it up and running. I'm pretty excited about the fact that I got it up and running, especially considering I paid 80 bloody quid for this thing. So hopefully the core is healthy, but yeah, we'll see. We'll see. I have high hopes. Like, it wasn't immediately artifacting when it turned on. And the thing is, I can't really run anything on the card right now because just the voltage drop across the current power connection is going to be atrocious. So I don't really want to try run the card. It's not going to run well. There's no real point doing that. Um, so yeah, I just need to finish this thing and like the actually no, you know what? There's one other idea I'm toying with on this card. So normally you put your power board on the front of the card because you have a very convenient connection where right where the inductors originally were, you can very easily connect your V core from the power board to the GPU. But with this card, we have this lovely power plane right over here, right? You can, yeah, you can see the line for that right there. So this is all V-core right here. There's just a lovely strip of V-core. And then there's a lovely strip of ground right on the other side of those capacitors. And what I'm thinking is like, if I, instead of putting my power board on the front, put my power board on the back, um, then I can actually run like an air cooler on this thing. That like even maybe use the stock air cooler that the card came with, which I think would be pretty neat because it would make it far more functional than the abomination it is right now, where you need a water block and like you need a core only water block, and then you need to deal with your own memory cooling. Which actually the stock heatsink situation probably, yeah, I'd have to cut the base plate for memory cooling, but it's not really a huge deal. So yeah, it's like that. That's one thing I'm toying with is maybe having the power board attached on the back instead of on the front, just because. Which I guess I could do that. Like the thing is, I guess I could just have like a very temporary connection for the Hall of Fame power board, bench the card. Once I'm done with benching the card, put the next put the smaller, more adequate power board on the back of the card, and then have it as like an air cooled GTX 1080. So, yeah, I don't know. Because, like, the thing I like, because I'm not sure, like, how other overclockers deal with having power boards attached to GPUs, but I don't like having, like, I don't like the idea of having a GPU that's, like, sitting in storage and doesn't have a functioning VRM on it, as in there's literally no vCore, right? Because this thing, it has no vCore. Like, if I take this power board off, there's no vCore. There's no way to get this thing to run. And I just don't like that. Like having it sitting in a drawer in a situation where it's like if you ever want to use the card, you need to pull it out, attach a new VRM to it, and then you can start using it. It's just like, hey, I don't like that. So yeah, and the funny thing is, I'll probably like if I attach the VRM to the back, it'll probably end up sitting in storage for basically forever anyway. So it's not gonna make that much of a difference. But it's just one of those things like I like it when I feel like the card is in a working condition instead of just a temporary condition. You know, like I want it to be finished. I don't want it to be like, oh, it needs work anytime I want to use it. So, yeah, even though I don't know why I'd want to use a GTX 1080. Like, funnily enough, if I did get this onto the stock air cooler, it would be an upgrade for my daily system. I could also bolt like a AIO to it and use it in my daily system, even with the current VRM situation. So it's like tons of options for what to do with this thing. But yeah, I've just not made up my mind what I want to do with it, other than I am definitely going to bench it. Like, not sure if I'm going to cool it with... it's a 1080. Pascal doesn't scale with like Pascal only scales with voltage if you get it really cold. So I'm kind of thinking I should probably take it on LN2. So yeah, maybe sometime you'll see this thing run on LN2. But for now, it's very much not like right now. It's still very much not finished. So yeah, but this video is finished for real this time. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the description. What? No. Down in the comment section below. There. I almost said description. Oh, there, I said it anyway. But yeah, so you can leave any comments, questions, suggestions under the video. And then if you'd like to support what I do here with the channel, as in like you would like to support my ill-advised purchasing decisions, there is the AHOC Patreon where you can support me directly. There's a link to that down in the description below. It also grants you Discord server access. And then there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And both of those help out immensely with running the channel and, well, my addiction to buying sketchy cards off of eBay. So yeah, I'd much appreciate it if you would check those out. That's it for the video. Thank you for watching, and goodbye.